Hello and welcome to this virtual NAB presentation of Reliable Internet Stream Transport. My name is Ciro Noronha and I am the president of the RIST Forum, also Executive VP of Engineering for Cobalt Digital. This presentation was prepared jointly with Adi Rosenberg, CTO of VideoFlow and also a RIST Forum director. So what's our agenda for today? First thing is going to be what are the challenges facing technical decision makers in the broadcasting industry. It's a mouthful and we'll get to that. Then what RIST can do for me, certainly solving those challenges. What is the RIST Forum? A quick overview of RIST features and benefits. And finally, some application scenarios and case studies. What are the challenges facing technical decision makers in the broadcasting industry? That's a mouthful, so let's look what they are. First, international contribution and distribution. Many changes in the broadcast industry are pushed by management and also by accountants because you have to solve the problem in a cost-effective way. You can do that by getting private lease lines from regional telcos, but those are expensive. Those are point-to-point by definitions, and the endpoints need to be serviced wherever they are. They may not be easy to relocate. You pay for the lines for 100% of the time, but they may lie idle for long periods of time. So those are challenges for that. Now, you can say, what about satellite? Now, C-band frequencies are going away. Those are being repurposed for next generation wireless. And if you're going to use satellite, that means getting the content there first. So it's still terrestrial transmission for that. And so we need to find some cost-effective alternatives. This is also more loss than the internet. All right, let's work remotely. That is a big thing now because you want to save money on travel and hotels. So you want to do your content workflows and remote production elsewhere. So in order to make that happen, you need to implement secure low latency solutions over the public internet. And with this virus situation, now that's become more and more important. Well, the cloud. Many workflows are migrating to the cloud, so places like Amazon Web Services and other things. The video needs to be moved around in the cloud, and you need to look at the trade-off between the cost of cloud storage and bandwidth against the on-prem costs. So can you migrate that? Can you integrate with cloud services? Can you get the content over there and then back? All right, those are challenges. Now, what can RIST do for me? So what really is the problem we are trying to solve here? The problem is I want to use the internet as a cost-effective means of transporting high-quality broadcast-grade video. But, and there's many buts here, the delivery to the internet is not guaranteed, so my video may glitch. I need to be able to use any combination of links, whatever I am, to move my content. Some solutions add a lot of latency, and that's not acceptable for live cases. They have to be low latency, the solutions. I need my content to get protected so that it doesn't get stolen. If it's valuable content over the internet, it definitely needs to be protected in some way. Another related problem is bad people should not be able to hijack my link. For example, I send a reporter in the field. That reporter is going to send some video back. Is it the reporter or someone else? It can only be the person that's authorized. Also, we're talking about internet. Internet means IT people are going to have to do something. They are very busy, so it needs to be easy for them. All right, you can say, well, I've seen solutions like that. Many vendors have either all or a subset of these features. So why is RIST different? RIST was designed as a joint effort between many of the leading companies by experts that combined have hundreds of years of experience, and those experts freely contributed to the effort. We selected best-of-class technologies for every aspect of the protocol, but the main purpose is to give you, the user, choice. If you all interoperate, all the vendors interoperate, you can choose the best possible equipment for your particular needs. You're not locked to a single vendor or to a single proprietary solution. and you do not need to compromise quality because we're looking at the best of breed solutions for the protocol. So that sounds all nice, but who's behind that? All right, so we have RIST is an effort that was created in the context of the Video Services Forum. The Video Services Forum created a RIST activity group. Those are the tech people. Those are the people who get together and decide on the technology. The output of that is the RIST specification. Then the RIST Forum is the marketing arm of that. These are the people who bring out the message out to the market and promote RIST. So there's a lot of commonality between these two groups. In fact, I participate on both. This is a list of companies that are today in the RIST Forum. You can see it's a who's who of internet streaming today. And that list is changing daily. So, all right, so how does RIST work? Let's take a look at an overview of RIST technology. Let's start with the timeline. RIST was created in February 17 within the VSF. It took us a year to come up with a spec, which we call the simple profile. We finished that during NAB, April 2018. In May 18, we had a first interop demo. It was a closed demo. We learned some things. We made some changes in July of 18, second draft. And then at IBC in September of 18, we had the first public demo. And then in October, we published something called the simple profile. Right after that, the RIST Forum was created to promote it. In early 19, we had commercial products available, another demo at NAB. And then in September of 19, we had main profile, and we had a public interop. And then in March of 2020, we published main profile, and we also have commercial products, including main profile. So what's this simple profile, main profile business? RIST is a layer of protocols. We start with simple profile. Simple profile is responsible for taking the content and getting it over there. The basis is an interoperable ARQ. It also includes link aggregation and bonding, when you can combine multiple links for the same into a higher bandwidth link. It supports redundant transmission paths for reliability, and also throttling of retransmission for stability. Main profile adds a few features. The first is the multi-stream tunneling, which is the thing your IT is going to love. It's only one port to open, and they can do it on either side. Next is encryption to protect your content, authentication to make sure that only authorized people can connect, and some nice features like high bitrate support and no packet suppression. This is also available. The RIST AG is now working on something called the RIST Enhanced Profile, where we're looking at things like smart bandwidth optimization, common channel session management, and centralized call home. So stay tuned for that. That's coming. Let me take you to a quick tour of each one of those things. RIST Simple Profile, the base standard is RTP, so it's compatible with RIST, with non-RIST devices without protection, and it has a number of features. Packet recovery is using ARQ. It's a technique got an Emmy award last year, and is a high performance. You can go up to 50% packet loss and still works. Also includes multi-link support. When you do bonding, you spread the data over multiple links to achieve higher throughput, and seamless switching when you send multiple copies, and if one of the paths go down, you switch to the other one without glitching. RIST is designed in such a way that companies are free to innovate and improve their products while maintaining compatibility. Main profile includes tunneling, where you can combine multiple streams into one UDP port. It simplifies IT configuration. The connection can be opened by either endpoint, and the tunnel is bidirectional, so it can go either way. There's also support for optional and out-of-band data, so you can use the RIST tunnel to manage remote devices. Encryption. RIST main profile offers configurable top-of-the-line AES encryption, and it uses DTLS encryption. It's exactly the same stack as what's used in the web, is what's used to connect to your bank. But with encryption, it's important to use something that's solid and has been vetted by experts, and that's what we did at RISC. RISC has also a pre-shared keys mode for one-to-many situations, which could also be used in satellite scenarios. Finally, RISC main profile includes authentication, which guarantees that whoever is talking to you is who you think they are. So the technologies used for authentication are the same as what you use in your bank. You have certificate-based authentication for both server and client, and you have a simpler password-based authentication for the simplest cases. Main profile also brings you other features such as support for bandwidth optimization, so you can reclaim some of the bandwidth without losing the compliance, and support for high bitrate operation, which will make it usable for even non-compressed video, although that is not available yet. This slide shows you all the standards used in RIST. It's a lot, and I'm not going to read them and tell you about each one of them. It's just to make the point that RIST is based on existing technology whenever possible. RIST products, okay, that's all fine. Can I go buy that today? Yes, you have encoders, you have decoders with RIST from multiple vendors. You have RIST gateways if you want to connect legacy devices to RIST. You can find system integration integrated with RIST experience, and even RIST services in the cloud. Open source, I want to add RIST to my product. Yes, it's ready for you. The main thing is librist, which you can just link into your product, and you have RIST. There's a GStreamer plugin, and it supported the new pipe. And if you want to test, VLC supports RIST, and there's a Wireshark plugin for RIST, so you can decode the packets. RIST is available in AWS Media Connect today as an ingest method, so it's very important. You can stream using RIST to AWS Elemental Live. All right. At every major trade show, we have a demo, a RIST demo. So we have one today also for virtual NAB. We have a server in Coral Springs, Florida, and a number of RIST clients all over the world sending content to that server. And this is mix and match of companies. So it looks like this. You have a certain number of companies that have servers in a virtual machine in the data center, and this other set of companies that are sending over the internet through those servers, and then we combine that into a nice screen. And this is running right here. So you can see that you have streams coming from California, Northern California, Southern California, out to Coral Springs, Florida, Virginia, Canada, Florida to Florida, Israel, another one in Canada, Sweden, and even Poland, all sending to that. And this is live, real time, happening right now. And this is going to be up until May 15. Here's an example of how good RIST is. That's from the demo you saw, not something happened historically, but it's showing here an 80% burst loss that was completely recovered. And this is between equipment from different vendors. Let's look at some use cases for RIST. Bidirectional transport. So the tunnel is bidirectional. So once you establish the tunnel, you can send it in both directions. That's a nice use case. The other nice use case is diverse load sharing, where you have links in parallel, and you can split the stream. Let's say in this case, I'm sending 10% over 4G and 90% over Wi-Fi, and then it gets combined. And again, this is multi-vendor compliant. The other one is seamless switching, where you send 100% of the streams over 2 or more paths. The receiver combines them, and if a path goes down, it seamlessly switches to the other without any glitching. Another very nice use case is PTZ Remote Production, where you have the video flowing in one direction and the camera controls flowing on the other direction, riding on the RIST tunnel. So the operator can control here and the talent's on camera over there. These were examples. Now I'm going to show you some sample RIST deployments. The first one is with Mankin Media. This is stuff that's working in the field today, again, in a multi-vendor situation. All the deployments I'm going to show you is multiple vendors. So Mankin Media has a service called Guardian, where they can monitor your stream. And you have encoders and decoders in RIST sending to the cloud to a transcoding farm that then sends it to YouTube, Facebook, and whatever. So that's happening today. Another interesting use case in the field today is Lockwood Broadcast. Again, Lockwood has encoders with RIST and servers with RIST. This is using main profile active tunnels with active and backup tunnels, and they all go into a server, and they use that then to transmit. They are bringing in news from remote sites to a central location. So that's a Lockwood Broadcast use case. Now, if you want to read about RIST, both simple profile, which is VSF TR061, and main profile, which is VSF TR062, are available out on the internet, free to download and use from the VSF website. If you want to join RIST, there's a RIST activity group webpage. You can go to RIST Forum for events, case studies, and there's a performance measurement study that was presented last year. All those demos I talked about, you can watch on YouTube. There's recordings of them. So just look for RIST demos on YouTube, and you will find those. You can also pause this information and copy those links. If I were in the same room with you, now I'll be opening for questions. Since I'm not, the questions have to be virtual. Send them our way at info@rist.tv, and we'll be happy to talk to you. Thank you very much for your attention.